Hello, this is the genuinely approachable Sudoku for the 26th of February 2024. It is Thermo Arrows by Clover, featuring more arrows that also act as thermos. So let's look at the rules. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits along each arrow sum to the value in the attached circle. So those digits, for example, sum to whatever that digit is. You could have something that looks like this, for example. This works as an arrow, but there's an additional rule where along an arrow, thermal rules also apply, where along an arrow, digits must increase starting from the point and going towards the bulb. So, for example, if this 9 was made of a 4 and a 5 here, you need to do this so that your digits increase like so. Right, so those are all the rules. With that, let us just begin solving. Okay, so let's start with this 8 then. Those digits must contain a 1 in them. And the reason why is because without a 1, the minimum you could put in here would be 2, 3, and 4. And therefore, would have to sum to at least 9, which doesn't work because this is an 8. So this digit must have a 1 in it somewhere, and because it's also a thermal going downwards, the 1 must be in the smallest position, which must be there. 1 can't be anywhere else because that would imply a digit less than 1, which doesn't work. Now those digits sum to 7 without using a 1. It's either 3, 4 or 2, 5 because you can't use a 1, 6. But it can't be 2, 5 because a 2, 5 following thermal rules would force a 2 here and a 5 there. The 2 here would break with this 2 here, which doesn't work. So it must be 3, 4 in increasing order to form your thermal. And now those digits have to sum to 8 but can't be 1, 7 or 3, 5. They must be 2, 6 once again in ascending order like that. Now this 7, those digits can't have a 2 or a 1 in them, so they can't be 1, 6 or 2, 5. They must be 3, 4, and also must be in ascending order up towards 7. Oh, we can do the same for the 9, yes, because of the 1, 2, and 3, those digits cannot sum up, those digits have to sum to 9. They can't be 1, 8, 2, 7, or 3, 6. They must be 4, 5, which is once again in ascending order. 7 now looks at those cells. Those cells are, one of them are 7. Actually, no, this 2 does help because those digits must be greater than 2, right? And therefore, those digits are at the very least 2, 3, and 4, which means that those digits sum to at least a 9. And because this digit is at most a 9, then it must just be a 9, which is made of 2, 3, and 4, which must be in increasing order to form your 9. Cool, okay. Alright, what now? I mean, that digit can't be 8 or 9, but it can't be 1, 2, 3, 4, or 5 either. So this is either 6 or 7. Okay, I don't see how that helps. This one maybe. Yes. Those digits are 3 separate distinct digits, which sum to a single digit number. Because those digits are at least 1, 2, and 3. Oh, they're not. This is at least a 2 because of the 1 here. So this is at least a 2, this is at least a 3, this is at least a 4, which is at least 9. So once again, by the same principle here, this must be 2, 3, and 4, which sums to 9. Oh, that's really sweet. Okay, so that means the remaining digits here are 1, 3, and 5. 3 here removes 3 from those cells. So that cell is now a 3. Sorry, that cell is not a 5. If it was a 5, those digits will be more than 5 because of the thermal, and that digit will have to be very, very high, which doesn't work. So this must just be a 1, that is therefore a 5. Now this digit, I believe is an 8 or a 9, right? Because it can't be 1, 2, 3, 4, 5, it can't be 6, it can't be 7, so it must be at most, it must be 8 or 9. Does that help? What does it say about those digits? I don't know what it says. Yeah, alright. Well, what about those digits? Those are 1, 5, and 8, sorry. Where that digit can't be 8. Right, this digit is once again at least a 6 because 1, 2, and 3 here sum to at least 6, so this must be 6 or 7. Right, because it can't be 8 or 9. Oh, which does mean there must be a 2 in one of those cells. Because without a 2, the minimum you'd have is 1, 3, and 4. Which sum to 5, which sum to like an 8, which doesn't work. So 2 must not be here because there is nothing between 1 and 2. So 2 must be here. This digit is now therefore either a 4 or a 5 to make 6 or 7. Oh, sorry, no, it's a 3 or a 4 to make 6 or 7. But the 4 here resolves that. This is 3, so this must be 6. Therefore, those digits are 4, 6, and 4, 7, and 9. Cool. We can probably do the triples here as well. Like those digits are 1, 2, and 6. 6 is in there, and then those digits are 5, 7, 8. Cool. Okay, 4 can't be in that cell. What does that do? No idea. Right, but let's look at where 9 goes in this box. 9 can't be on here because that digit is less than 9, so you can't have 9 plus something else add to 6 or 7. 9 by this digit here can't be there, and so in this row has to be one of those cells. There is a 1 here, I think, in this arrow. And I can say the reason why is because if it were a 7, it can't be 2, 5, or 3, 4. It would have to be 1, 6. And if it were a 6, it can't be 2, 4. It must be 1, 5. So there must be a 1, 5, 6 in here. And because it's a thermo upwards, this digit must be a 1, which is because it's the lowest. Actually, you know what? This digit is at least a 6. We know that because it's 3 digits. But can't be a 6 or a 9. Nice, so it must be 7 or 8. This 1 means that is no longer 1. What can we do here? Maybe this is also similar. If it was an 8, you can't use 3, 5. You can't use 2, 6. There's a 6 there. So it must be 1, 7. If it were a 9, you can't use 4, 5, or 3, 6. Could you use 2, 7? You could use 2, 7 or 1, 8. So I guess it's not that constrained. This digit definitely can't be as high as a 7 or 8 though. And same, that digit can't be as low as a 1 or a 2. So I guess we have that to go with. Not sure if that helps. It might. There's also an arrow here which we never looked at. This one has to be at most a 7 because 8 and 9 are already outside. But I don't know how that would help. Well, let's look at some other Sudoku. 3 in this box can only be here. Therefore 3 in this box, well, firstly 3 in the corner. That puts a 3 here. Which means 3 in this box must be here. I think that gives us all the 3s. It does. You can do other stuff. Yes, the 4s in this box must be in here. Therefore in this box must be here. Therefore in this box must be here. That does give us all the 4s. What about the 2s? A lot scarcer. The 2s are a lot scarcer. I guess 2 can't be there because you can't make those cells come to 2. They have to be both 1s, which doesn't work. So 2 has to be one of those cells. And in fact, this digit can't be 2 because if it was 2, by thermo it would force this to be 1, meaning this would have to be 3, which doesn't work. So 2 has to go here. In this box, therefore, 2 must be in one of those cells, but can't be further away from here because of the 1, and the 2 can't have anything between 1 and 2, so 2 must go here, which means that digit is no longer 2. How does that do anything? Well, 2 in this box is in one of those cells. We don't know which. Alright, fair enough. I don't think we can do anything else with the 2s anymore. Or the 1s. Oh, even worse. It's not that bad. I guess 1's in one of those cells. 1's, yeah, 1's in one of those cells as well, by regular Sudoku. 1 in here are in one of those cells, which doesn't do much. Alright. Sure. Well, this is at least 1, 5 because 2, 3, and 4 are already outside, which means that this is at least a 6. So I guess I can mark this as either 6 or 7. If it were a 6, it would be 1, 5. It would be, if it was 7, it would be 1, 6. And in both cases, 1 goes at the edge, which means that is no longer 1. Gives you another sort of X-wing pattern here. But this digit is now either a 5 or a 6, which once again means something. Still have no idea what that means. Oh well, 4 means 4 can't be here, so 4 must go there. That gives us all the 4s, okay. All the 4s. 1, 5, actually this forms a triple, is 1, 5, 7. 1 can't be here, 5 can't be here. So it gives us another chocolate teapot, lovely. I feel like this is something, but that's way too many digits. That forms a triple though. This is 5, 7, and 9 as a triple. This digit can't be 5. That could be anything. Those digits also form a triple. 6, 7, and 8. We don't have anything on that. Those also form a triple. 6, 8, and 9. Which also don't give us anything. So that's just great. Oh, I'm sorry, this digit, right. Because if this 7, 8, right, this has to be either 4 or 5 to complete this sum. But because of the 4 here, this must be 5, making this an 8. This 5 gives us no 5 here, which means 5 in this box must be there. 8 can't be in here, which means that 8 in this box has to be here. 5 here, sorry, 5 doesn't do anything. 5 here though, gives us a 6 here, which gives us a 7 there. That resolves this entire, chocolate teapot looking abomination. This is a 6. Those digits are 5 and 9, which I don't know if we can resolve that yet. And then those digits are 7 and 9, which again I don't think we can resolve. This 2, no, this 6 resolves this though. This has to be a 1, that's 2, that's 6. This 1 means 1 has to go here. 8 means that digit is no longer 8, that digit is no longer 5. This 5, 7 means this is either 5 or 7. What else do we have? Here we are missing we're missing a 2 somewhere, but 2 can't be here. So in this column, 2 can only go in this cell, which gives us a 1 here, which gives us a 7 here, which gives us everything actually. 7 gives us a 5 here, which gives us a 1 here. Those digits have to be 2 and 6, which we can resolve. How do we resolve this? 8 here resolves that, which continues down the chain. 9 resolves the 7, 9. Actually, this 7 also resolves whatever thing we had here. Okay, what else do we have? 5 means that is now 7, therefore that's 5. 6, remove 6 from that cell, so 6 in this box. Actually, this 9 resolves everything immediately, which is good. 6, those digits have to be 5, 8, and 9. 5 and 8 can't go here, so that's 9. This is now a 5, 8 pair. This 5 resolves that, which now resolves this 7, 8 pair, which now resolves this 7, 9 pair, solving the puzzle in 12 minutes and 8 seconds. Awesome. Okay, very cool concept. Yeah, I hope you enjoyed that puzzle. I'll see you next time. Bye bye.